right, this is lesson 7.4. We are going to be solving logarithmic equations, and we're going to take a look at two different types. So it does matter which type you're going to do. That will help you in solving. So we're going to go ahead and rewrite as an exponential equation, so that way we can solve it. So remember, this is our base, 6, our exponent out here, 2, and then our solution, x. So now that it's rewritten, we can definitely see that all we have to do is take 6 squared, which is 36, and there's our answer, x equals 36. So for that next one, we are going to rewrite it. We have a base of 9. We have an exponent out here. It's still, even though it's not written equals to on this right side, it still equals to on this side, which is still your exponent. And then that equals, and then here is our solution, negative 3x. So now what we're going to do is simplify that, and then we're going to divide by negative 3. So x is equal to negative 27. So for this next one, again, rewrite. So it's 3 is our base, exponent out here what it's equal to, and then it equals, and that's our part written right here, 4x minus 1 over 3. And then we're going to simplify. This is 9. And then if you just create this as a fraction, you can use cross multiplication, and it's a lot easier. So put that 9 over 1, and then just cross multiply. So we end up with 4x minus 1 equaling 27, and then add 1, and then divide by 4. And you wind up with x equaling 7. So let's go ahead and have you try a few. We're going to do number 4 together because it is going to be a quadratic, which we'll have to factor, but then I'll have you do these next two on your own to practice. So let's take a look at number 4 together. Remember, a quadratic equation is solved by making one side equal to 0, which we'll see in this number 4 here. So let's rewrite it first, just like we did on those previous ones. Base of 2, exponent of 5 equaling x squared plus 4x. So simplifying our power here, just like we've done before on the ones above. Now we see that we do have that quadratic. We have something that's x squared, and it's not going to go away. So that means we do want to get that one side equal to 0, which means to subtract that 32. So now that it's equal to 0, we're going to go ahead and factor. So what are the factors of negative 32 that add to get 4? And that would be 8 and negative 4. So we're going to put plus 8 and x minus 4. And then we're going to set each of those equal to 0, and we're going to solve. So x equals negative 8, and x equals 4. And we're done. So do realize that if you do get something that's squared and it doesn't go away, you are going to either need to do the square root property or maybe factor by getting everything equal to 0. So I want you to try these next two on your own. Remember that since there's nothing written here, it's that common log, which means that there is that 10 that's kind of invisible right there. So that's the common log. And it's like there's a 10. So keep your base as 10, then put your exponent in, set it equal, and solve. So try 5 and 6 and check when you're ready. All right, so let's go ahead and check. Base of 10, 10 to the first, here's our exponent, equals 30 over 2x plus 7. So if we just put this 10 over 1, then we can cross multiply. We do need to distribute because this 2x plus 7 gets put in parentheses here. Subtract your 70, divide by 20, and you get negative 2. Next, 16 to the 1/2 power. Remember, fractions are basically just, as your exponent, are just the square root, the cube root, etc. So think back to that as you're working to simplify those. So square root of 16 equals 2x. So 4 equals 2x, divide by 2 to get 2. All right, let's take a look at the last little bit, the second type that we're going to learn about here. So what it says is basically if the log equals the log, so those logs are the same base, then we can set what's inside equal. So the x and the 8 would then be equal. So we first need to make sure that we have that single log equal to the single log, and then it's matching, then we can set those parts equal. So let's take a look here. First, check that. Log 20, yep. So now we can go ahead and set this equal to this. So negative 2x equals 10 minus x. And then we'll solve. So add x. We get negative x equals 10, but we don't want that negative 1 in front, so we're going to divide by that negative 1. So x equals negative 10. So one more time, check your log. We're good. So now we can go ahead and set those parts equal. So it's x plus 5 equals 2x minus 10. And then we're going to subtract. I always subtract the smaller x. That way we don't deal with negatives, but over here we still dealt with negatives since we didn't want anything all on one side. So this is going to give us an x minus 10. Add that 10, and we get x equals 15. So go ahead and try those last two on your own, and then we'll check when you're ready. All right, so let's go ahead and check these last two. So the logs are the same. So we're going to put the x squared equal to the negative 6x minus 8. Notice that we have something that's squared, so we want to get everything to one side. So these last two were quadratics. Hopefully you caught that. If not, let's talk about it. So everything to one side since we have that x squared. So now everything's on one side equal to 0. Factors of 8 that add to get 6, 4, and 2. So put an x plus 4 and x plus 2 equal to 0 to get our answers of negative 4 and negative 2. So here, logs were the same. We could set these equal. Again, we have an x squared that's not going to go away. There's no other x squared we could subtract for it to cancel. So it's still going to be there. So let's get everything to one side. Subtract your x, subtract your 3. Here's what we get, set equal to 0. Come up with factors of negative 6 that add to get negative 1. Which would be negative 3 and 2. Put those inside the parentheses and set those parts equal to 0 to get your final answer. So those are the two types. Look those over, make sure you know both of those, and we will practice on Friday.